to maybe see. You can see if you're actually in the video or not. All right. Let's see. All right. Hey, everyone. My name's Alex, and I am the organizer for Nashville Data Nerds. This month, we have Josh Pack with Carla Schrader. I'm going to talk about data governance and the other boring stuff. I'd like to also thank our sponsors this month, Belmont for providing us a space, and Information Builders for providing us awesome coffee and chicken wings. Oh. All right. So without further ado, let's get. No problem. Yep.
I can't see myself, so I don't know if I'm on camera.
You probably won't be on camera.
Okay.
So we optimize for just getting in on there.
Perfect. So good morning, everybody. I'm Nicole Dixon. I'm with Information Builders, and I really appreciate the opportunity to come in today and be the coffee and breakfast sponsor here for Alex's Data Nerds meetup. I want to just give you a quick introduction to me and the company that I work for, Information Builders. So I mentioned it to some folks in the room before, but I'm one of those rare birds in Nashville that was born and raised here. And I have a deep love of healthcare, learning, and data, which brought me to join the team at Information Builders. Information Builders is a data analytics and BI company that has been around for over 40 years and has recently decided that they wanted to bring on a team with a healthcare background to focus on technology, analytics, and BI, specifically in the healthcare space. Oh, here we go. So if you take a look here, you can see, population health, AI, machine learning, value-based care. These are all hot topics of conversation in this time within healthcare and in technology. And you'll notice at the center of all of these hot topics is the one thing that we know and love, and that's data. Oops. Can you take the back one?
Just hit the arrow.
Sorry, I'm a Mac person, so I'm not Windows savvy. So at Information Builders, we break down our solutions into three components. On the far left, you'll see Omni Health Data for providers and payers, and that's our enterprise data analytics and BI tool. In the middle, you'll see the second piece of our solution, which we call OHD Insights, and these are pre-built info apps that we worked in conjunction with St. Luke's up in Pennsylvania to build. And then the final piece of our solution is Web Focus, and this is an enterprise intelligence BI tool similar to a Power BI or Tableau. Just drilling down a little bit, I wanted to focus briefly on that first piece of the puzzle, which was our enterprise data intelligence and BI tool. So starting over on the left, we bring data in from multiple sources, match, merge, and cleanse it. We layer in code sets, value sets, and algorithms, and then bring that data out in an easy-to-consume layer. So that can go into our Web Focus tool or into your existing BI solution. I'd love to tell you more about this, so if it's something that interests you, please don't hesitate to reach out to me. You can see my email address here, Nicole_Dixon@ibi.com. You can also hit me up on LinkedIn. For those that were able to attend today, I will be doing a drawing for Amazon gift cards. So fingers crossed, I'll circle back to you on that. And then mark your calendars, December 4th, I'm doing an event at Peg Leg Porker where we're hosting a speaker as well as barbecue and happy hour, talking about getting your data out of the data jail. All right, without further ado,
All right, thanks. All right, thanks everyone for having me. Thanks to Nicole, thanks to Alex for setting up this meeting. I know we've got a few people on the broadcast out there, so thanks for attending on this cold day. My name's Josh Pack. I'm with Keller Schrader. We are a regional IT consultancy, originally based in Evansville, but we're also here in Middle Tennessee and Western Kentucky. And we have sort of infrastructure services, apps development services, and staffing solutions. And we recently formed a data strategy group, which is focused on the topic that I'm going to present today, data governance and other boring stuff like it. And then we have an analytics team. And my partner and I, Tom Bargu, is here today. And we're happy to talk to any of you afterwards and hope to meet all of you. So thanks for attending. So just a little bit about me. Again, I'm the principal consultant at Keller Schrader in the data strategy group. I've held positions as a senior data scientist in energy and utilities and also the banking industry. Have really enjoyed that. Had a broad set of experiences in the utility industry as well prior to being a data scientist. As a manager of energy technologies, I was responsible for coming up with renewable energy and clean technology strategy for a company called Vectren based in Indiana, recently acquired by CenterPoint Energy out of Houston. And in that capacity, I got to see a lot of really interesting utility case studies and use cases. And then prior to that, I had roles in BI in kind of the early days, way before there was such a thing as Tableau, and there was no such thing as big data, and no such thing as data science. They just had other names at the time, of course. And so predominantly an energy background, but in graduate school, I studied biofuels and industrial agriculture, and had some great experiences there at Cornell. So my original degrees were in environmental engineering, but in grad school, I really fell in love with operations research, which was kind of a predecessor of what we think of analytics today, and it's still around. It's kind of been incorporated into analytics. I did supply chain research in biofuels. So that's really where I kind of became a quant, if you will, and that really propelled my career in energy. And so I've been really fortunate. I've worked with my colleague Tom here in the room for over 15 years now, and we're really excited to have launched this data strategy group at Keller Schrader. We really focus on trying to help organizations prepare for analytics, maybe at a deeper level than they thought they needed. And that is to speak to the data governance topics and the other topics that I'm going to cover today. And you'll see that there's a theme of culture in here. Not only are we analytics and data management consultants, but we're just as much culture consultants. It's very important to have a data culture, as you all know. And then I'm a proud father of 2 boys and happily married and live up in a nice little town in southern Indiana. We love coming down to Nashville. We're down here really often and hope to meet you all. So in this presentation, I'm going to take some of these quote unquote boring topics. I kind of prepared this from the perspective of a new data scientist that's new to industry. Perhaps some of the folks in the room are more experienced than that, but regardless, these topics, as we were discussing earlier, these get thrown around a lot, and they mean different things to different people. They mean different things in different industries and different companies. And so data governance is really the last thing on the list, because you can't really do that well until you've thought about all these other concepts. So data lineage, data provenance, or the data origin, data quality, metadata management, and then finally data governance. All these topics in our lexicon, we like to think of these as data lifecycle management. And so when we go into our clients and explain what we do, we really start with this theme of data lifecycle management and then break it down from there. And of course, we do support analytics use cases. We have a really highly technical team and a lot of smart quantitative folks, but we really try to lead with data management and data lifecycle management. So the first thing I want to go into is data lineage and provenance, all right? So the origin and the pathway and the life cycle of data. And I was going to inject some humor in here today. So I have a really brief segment. I don't know if there are any Portlandia fans in the room or on the webcast, but in this, you might even recognize the scene already if you're a fan. So I want you to think of the waitress as the analyst who's trying to sell her analysis that she's done a good job with. And I want you to think of Fred and Carrie as the management team that she's presenting to. She has to convince and persuade that her analysis is correct. And then think of the chicken in the story as the data, okay? So you gotta kind of project all that onto this video, but you're gonna really like it if you haven't seen it.
Thank you for having me that back the other day. Come on, it's more for me than you. God, you have beautiful eyes. Everyone tells me that. I'm the only one that told you that. No, I don't mean like in a flirty way, but people as a kid, like you have great eyes. It's like.
Let me turn it up for you all here.
Thank you.
I guess I'm only at 50%, so here we go. I'm gonna blast it.
Do it.
Sorry for that. Here we go.
Thank you for having me that back the other day. Come on, it's more for me than you. God, you have beautiful eyes. Everyone tells me that. I'm the only one that told you that. No, I don't mean like in a flirty way, but people as a kid, like you have great eyes. It's like I'm just a guy. You're my guy. I am your guy.
Hey guys.
It's ridiculous.
Hi, it's Dana. I'll be taking care of you today. If you have any questions about the menu, please let me know.
I guess I do have a question about the chicken. If you could just tell us a little bit more about it.
The chicken is a heritage breed, woodland raised chicken that's been fed a diet of sheep's milk, soy, and hazelnuts.
Okay, this is local?
Yes, absolutely.
I'm gonna ask you just one more time. It's local.
It is.
Is that USDA organic or Oregon organic or Portland organic?
It's just all across the board organic.
Hazelnut, is it local? How big is the area where the chickens are able to roam free? I'm sorry to interrupt. I had exactly the same question.
4 acres. Give me just a second. I'll be right back. Okay.
Okay.
Just a few more seconds here.
I want to apologize. I drove way too slow here today, didn't I? I'm so weird at that gas pedal. I can just moves the whole vehicle forward.
Right. So here is the chicken you'll be enjoying tonight.
You have this information. This is fantastic.
Absolutely. His name was Colin. Yours, Hazelnut.
It looks like a happy little guy who runs around. A lot of friends, other chickens as friends, putting his little wing around another one and kind of like going around.
I don't know that I speak to that.
Okay, they got her, right? She can't speak to that intimate level of knowledge. Okay, so that's the point in the presentation if you're the analyst, where they don't believe you anymore. They don't trust you, okay? So she answered all these great questions. She had done her homework, but she finally got to a point where she couldn't answer them. And so what they do is cast doubt on all of her work, okay? Has anyone been in that situation? Yes, right? Okay, so that's why I love this analogy of farm to table and local food, right? That we demand to know where our meals have come from. But in the business context, you kind of have to just trust or believe someone, right? That the data is where they say it came from. So why don't we know where the data on this dashboard came from? It's kind of a rhetorical, right? Let's assume that you do really know, like all the transformations in your data. You know exactly where everything is coming from. You've talked to all the developers and DBAs and business experts, and you know, and even have documentation. Let's say that you've got all of that, all right? But you're new to the company. Maybe the executives that you're presenting to don't know you. They might start to ask questions like, now, isn't this the analysis that Mary used to do? Or have you talked to Jim about this? Does this data really work? Did you do your homework? So if you're that person and they don't know you well and they don't trust you, they're casting doubt on your work. Okay. So this is Ron Burgundy, of course, saying, I don't believe you, and just casting your analysis aside. All right. So bringing everything into question. So the data lineage is in question, because if you haven't proven to their liking where it came from, then you're out of luck. Your analysis may not even go any further. Similarly, so that's data lineage, and then a special subset of that is data provenance, the origin of data. So we might know exactly where this chocolate came from, right? Where it was grown, where it came into being. But if you don't really know where your data is created, it's still casts doubt on your work. So you end up in the same predicament. Somebody can bring into question how that data came into being, all right? And that messes up the entire pipeline too. So now your data and your dashboard is no longer trustworthy, all right? So, there are a lot of definitions out on the web for these terms, and I like to think of them as distinct. Data provenance is where the origin of the data is, where it came into being, how it was really created. And data lineage is the end-to-end journey of that to the point of use, all right? And then I'm kind of a francophone. I had some internships in France, and I love the fact that this comes from the French word provenir, which is related to lineage and pedigree. And so this kind of blend together, but it's important from a data perspective to pull them apart, okay? And, data is created in lots of different ways, right? You might have what you would call pristine data or mouse click data. I jokingly call it West Coast data. If it comes from the internet giants, it must be right. It's perfectly clean, it's perfectly governed and all of that. Of course, we know that isn't necessarily true, but this data might come to a data scientist, and then they, do some cogitation on it and create value for their companies. However, a lot of data in the real world is created the old-fashioned way. And I've got some images here, hope you can all see. Clipboard data, people walking around recording information that they see with their own minds. Fieldwork data, we've got some farmers gathering, picking fruit. We've got a construction site. Data is being created there, right? It just isn't mouse click data. It's stuff that's happening in our economy that we need to record in some way. And then inventory, keeping track of commodities like timber or coal or minerals. Process data, this is a crucible of, I believe it's aluminum, being created on a huge scale. There's data there too, right? There's IoT controls and things, and then that's a wastewater site where there's plenty of chemical controls and sensors and all sorts of things. And so this old-fashioned data is collected in new ways. I was at the doctor's recently, and I really like this device. It's I forget what it's called, but it's a patient intake tablet. Maybe some of you have used it. And as I was holding it, I was thinking this is a really nice analogy for how things have changed in healthcare. And then if you have any farming friends or family, you know how advanced combines have gotten, right? It's amazing. Like GPS and helping a farmer to know, oh, in this exact acre, I got such and such a yield last year, things like that. And then this is an image of forestry guys counting their inventory before they've ever cut the timber down, right? And then there's all kinds of process screens that I could flash up here, but believe me, the industrial processes have tons of data being created, and it flows to their application databases and so on. But all that said, does bringing old-fashioned data into a digital environment, into a database, make it any better? Does it make the quality any better? That's another rhetorical, all right? Which leads us right into the topic of data quality. Because if data is created in so many different ways, there's got to be a lot of different ways to manage, or at least have like a comprehensive strategy and nomenclature for being able to manage and improve your data quality. So I'm going to launch in a couple of case studies now. And the first, with an energy and utility background, like I mentioned, we're going to talk about gas pipeline safety. Okay, so it hasn't been very long ago, and you'll remember in the news there was a huge series of explosions in some relatively prominent suburbs of Boston, Andover, I think Lexington, and those made a lot of news, right? And there's going to be lawsuits and all sorts of things. But prior to that, there was an explosion in California where damages and loss of life in San Bruno, California. And this really kind of brought into being a very heightened awareness and set of data requirements on gas utilities to really have a much more controlled program for keeping track of pipeline inspection, pipeline materials management, and utilities were not prepared and are still reeling from the requirements that were created from that. And in fact, an agency was created called PHMSA, which is Pipeline Health Management Safety Act or agency. And they, of course, track all these damages and create all these regulations. So that's the backdrop to this case study. So we like to use an analogy in speaking about data quality and data collection that we like to call it a glacier core sample. So think of your business and the way that it has collected and gathered data over time as a glacier. And then think of taking a core sample as like an examination back through time of how your organization has collected data and tried to improve the quality. So using that mental image, what are some of the ways that we can measure or evaluate a data collection program? And you may not be able to see these on the webcast or in the back, but I'm going to set out a little table here. And some of the ways that you can measure your data collection is how many different data elements or fields or columns are you collecting for each observation. So for each inspection, on how many different pieces of info are you collecting? What's the quality of that data? And then how much does it cost to collect that data? Okay, those are some dimensions, really important dimensions of evaluating a data collection process. Well, so with pipeline inspection, and of course, thinking of a particular client firm here, they had a very traditional way of collecting data on a clipboard, right? And you had inspectors that took great pride in what they did. So they collected, let's just call it a medium amount of data elements for each observation that they took. The data quality was actually very high. You might not think so, but they took such great pride and were very meticulous about what they did, and they were highly trained. So each form was filled out precisely, for the most part, right? And that was obviously really expensive to do. You got all these people out in the field with clipboards, driving around in trucks, inspecting pipes. And the value of that, if it's all based on paper, just to gather any kind of reasonable scale of data was really difficult, right? You had to have some admins entering data, and then that data conversion may have had problems. And even if they got a lot of data, it was still, not a ton, not enough that you would want to really do a lot of statistics on. So the value to analytics is this blue column over here, and I'm going to call that manual, which is kind of like saying there really wasn't much analytics going on. And then the IT group and the pipeline operations management team decided that they needed an application and they needed ruggedized PCs in order that these inspectors and technicians could go out and take the data and enter it right on the spot, okay? So you would think that that was an improvement. However, because they were asked to try out a new system, and it really kind of moved their cheese, right? You know what I mean by that? That the idea that this was a whole other system and they were not used to this, and they missed their paper forms, and they don't even really like to use computers very much, okay? So a high number of columns, the data quality was really low because they were asked to collect more stuff than they had in the past. They weren't used to the forms were not intuitive to them, and so on. And so the data collection costs actually went up because they were still using paper forms and the computer and driving themselves crazy and getting stressed out. And so the data quality went down, the cost went up, all right? The exact opposite of what people wanted. And the value of analytics, you could say, was even lower. You've got data now and it's at scale, but the data was not very useful, okay, because of the quality. Then version 2.0, what they did is reduce the number of elements that were being collected. This made it a little bit easier. They actually went out and listened to the field, the program managers and IT staff. Maybe a little too late, obviously, but this was a state where they got a lower number of data elements. In fact, almost lower than what they had been collecting originally on the forms. And the data quality was better, but still not great. And the data collection costs got lower because they kind of got through that learning curve and they're collecting fewer items now, okay? So that was a long evolution, right, to get to low value to analytics, because you still got medium data quality, right? And it's not, in some cases, it's not like the data scientists can go in and massage it and impute it, because the data is just not there, or you don't have the real values, you know? So depending on the use case, you're going to end up with cultural acceptance that's either there or it's not, okay? And so really the theme, like I've been talking about, is culture here. So cultural acceptance back in the day was very, very compatible. I mean, people were used to the paper form, and that was what they did. They almost identified with the form. And then they got a lot of resistance when they first launched 1.0, right? And then eventually they reached the state of compromise, which is never where the management team wanted to be. And nobody was really happy, but they kind of reached this steady state, okay? And I'm going to be honest, it's not a lot better than that today. So after all that investment, you know, you got to ask yourself, was it worth it? And is analytics really being helped by that? So that's the case study. And you still have data quality in question. So remember, this is my little chapter on data quality. And the premise is that the forms design and the attention to culture can really affect quality. And so to generalize that case study more broadly, think about a business. All businesses create data. They have a strategy for making money. That data has to flow through business processes. And those processes are supported by activities and people and things happening day in, day out. And then each of those, I just have some generic, like financial system, operations system, customer system, and so on. Each of those business processes in those rectangles relies on a database or a system or an application of some kind, all right? If you're lucky enough and your management believes in it, you might have middleware, a kind of an integration layer where developers are not having to build custom connections between applications. Really powerful, and we really espouse middleware. It can be expensive, but it pays for itself. If you're lucky enough to have that, your innovation cycles are better, because now you're not having to build all these custom, you know, data gathering tools and ETL jobs. You kind of have a more standardized, we call data grand central, where all data kind of conforms to certain formats. And then, of course, the data warehousing layer can be helpful for BI and analytics. And then data lifecycle management, which we're talking about today, helps to enrich that. And then if you're really into advanced analytics, you might have this unstructured schema on read data lake where you're deploying your innovations and your models. You've got business operations at the top layer. You've got innovation going on down here. But here's my Pac-Man. Again, if your management team has not addressed the cultural dimensions of this, it can all go away, be dismissed, or never be effective. And this, you may not be able to see this quote, but the famous investor guru guy said, Peter Drucker said, culture eats strategy for breakfast. So that's a visual for you to take back and really try to espouse at your companies and champion for. You got to pay attention to culture for all this stuff to work.
I think the example that you gave earlier, you know, with changing from the clipboards to the database is such a prime, like, textbooks example, right?
Yeah.
Like, it's a case where, you know, you think about two groups of people getting the data and people wanting to do stuff with the data.
Mm-hmm.
All kind of have or should have the same end goal.
Yeah.
But they don't think about each other.
That's right.
And I think it's honestly more on the people that are putting the application together.
Yeah.
They don't think about, like, what they're going through. And in that middle section, like, it was so obvious they were trying to change too much too quick, right?
Yeah.
Like, if they had taken just the clipboard and only gone to digital, like, their chances would have been so much higher. But they're just trying to change too much and not having communication buy-in. Like, it's so interesting because, like, even like with your video and stuff, like, it's just been my experience that when you try to communicate data, like there's two parts. One is like knowing the data, which the waitress definitely did.
Yeah.
But the second is just being able to like communicate that part, right? Like it's so interesting. And some people are never going to be there, and some people will. But yeah, these are really great examples.
Yeah, thank you. Thank you for your comments. Yeah. This is the first time I've presented this, and it'll probably get more traction and evolve over time. So thanks so much for the feedback. I'm glad it's resonating. We can talk more and jump in anytime, by the way, right?
Yeah, absolutely.
Questions anytime, right,
Yeah,
Alex?
question anytime.
Okay, so the next
conversation.
little chapter here is metadata management. So some of you may know exactly what I mean by metadata. Some of you might have kind of a clue, and some may be new to you, and that's all right. So now I'm going to move to the financial industry. This is a neat case study. There may be someone in the room who lived through this. And what it is there's a data scientist who has been given an assignment, a relatively straightforward assignment, really not any kind of prediction, just trying to gather and do some reporting on the time that it takes for customer service reps to do transactions with customers, okay? There's a little bit of color coding in here. You're going to see some circular like nodes. Each node is a person. The white is the analytics team. The blue is business operations, or operations staff support, and then the yellow is IT, okay? And each little line or arc that you see between the nodes is a communication of some kind: email, phone, meeting, whatever. All right, so this is our hero, the data scientist. Gets an assignment from his boss, talks to some of his colleagues to make sure he knows what the boss is talking about, gets some feedback from some business folks, finds where the data is, tries to identify, has this ever been queried before? Then talks to the senior vice president who actually asked for this thing in the first place to make sure he gets the scope. That guy delegates everything and never talks to the data scientist and has to kind of clarify with the delegate. The delegate didn't even know what the senior vice president wanted. These yellow IT folks on the top have a lot of communication with the data scientist, because the data scientist realized that only 90 days worth of data was available and the rest was being archived. And archived almost means impossible to get, okay? And so all these conversations that you're seeing here is like, how do we restore this data? Can it be restored? Where is it anyway? Where is the archive? How are we going to bring it back? What technology are we going to bring it into? Okay, this data had never been restored from archive. So there's a quarterback up here in the IT group that's trying to manage all this, and he's like, gosh, this is going to take a lot of work. And it's a relatively straightforward analysis that the data scientist is asking for. All right. And I don't know if one of my updates already came up there, but I'm updating like how many emails, how much communication. At this point, 116 emails, 22 voice calls, 13 meetings. The CFO has gotten involved because he's trying to keep this project alive. Think about that. And he's negotiating with the CIO that we actually want to restore this data. Yes, please restore this data. And then another senior vice president gets involved because the original senior vice president is too busy to talk to the data scientist, okay? And she's really annoyed that she has to work with the data scientist. So after all that, 122 emails, this is just the communication, just the emails, okay? And the phone calls and the meetings, estimated at 114 hours. And I, put some labor rates in here to try to tabulate maybe $10,000 worth of emails and phone calls. Remember, the CFO's in there, right? And all this communications over a span of 4 months, just to try to measure how long it takes customer service reps to do transactions. So all of that is a case study to show that the metadata was really the root of the problem. Nobody knew where the data was. Nobody knew what the queries meant. The field descriptions were very ungoverned. They were in sort of tribal knowledge, if you will, spreadsheets. And you had to kind of cross-reference to make sure everybody believed that's what these things mean. And then even the meaning of the transaction codes themselves was in question. So backing up a second, what's metadata? Well, think of metadata as having 3 main aspects or types. The physical metadata is where is that data? What server is it on, or what cloud instance? and can we find it? And then logical metadata is all about the data structure. What are the fields named? Where is the schema? What's the schema called? How are the tables in relation to each other? And what are the permissions on that, and so on. So that's all kind of like, and you might think of it as like the database management of the data. And then finally, the conceptual metadata is the business metadata. Okay, so that is like, stop thinking about IT for a second. What does this field in this database mean to that business person? Okay, somebody who has no technical knowledge, if you try to explain a column to them, what does that mean to them? How is it used in the business? Might mean different things to different people. And believe it or not, that is usually the hardest part of metadata management, is the conceptual. So I'm not going to speak through all of these, but I've got a bunch of lessons learned from that case study you just saw. Field descriptions were not well known, so you had to do all this homework to figure out what it even meant. The filters on which data elements are we interested in? Are there any transaction types that don't belong in the analysis? Nobody knew. You had to really build that from scratch. Data retention was only 90 days. Like I said, that created a huge restoration project, and it was hard to even find that data, and how do we bring it into a new source so that it can be used for analytics? Transaction types not formally defined. And then this was really the kicker, and we kind of knew this from the beginning. The transaction types themselves, you couldn't actually measure how long they took. You had a single timestamp of like when a customer was speaking, but not how long that event took place. So a time study was done with an army of interns observing these transactions to try to impute like an average time for each transaction type. Very, very wasteful. And if the system had been designed in such a way that you could capture how long things took, none of that would have been necessary. You would have had the precision you wanted. But some banking systems don't even really stamp the beginning and end of transactions. So all of that, we've talked about data lineage, data quality, metadata management, and now we're at data governance. So the best way to describe data governance is really with another example. So here I have a very simplified sketch of a power plant, okay? May have heard of acid rain way back in the day. It was one of the reasons that the Environmental Protection Agency was created. That came from sulfur dioxide, which is a byproduct of burning coal and coal-fired power plants. So the early scrubbers, which were kind of being built in the 70s, scrubbing is simply, you may know, but for those who don't, it's simply a chemical process to remove that sulfur dioxide before the gas goes into the atmosphere. So a particular type of scrubber is using a scrubber chemical that's $135 a ton, which for a commodity chemical is very expensive, okay? Maybe 10 times other kinds of scrubbers. So any inefficient use of this scrubber chemical costs this power company millions of dollars every year, okay? So you want to try to dial that in, right? Now you would think that after decades of managing this, that they would have that down to a precise science. This is a screenshot of what's called a DCS, a distributed control system in a power plant. Don't worry about what's in there. I'm just illustrating that all this data is flowing in from sensors, thousands of sensors throughout the power plant. And that sensor data, in most cases, is being collected every 2 seconds. The data integrity is very high. Everything is very well documented because this is an off-the-shelf product from a very prominent vendor. And you got to believe that their data structure is set in stone, right? Okay. So that's really good. However, and let me also say that even though they didn't think of it as data governance, this data was pretty well governed. They knew what it meant. They knew where the data was. They knew the structures and all that. So think of it as kind of like not formal data governance, but all the right things were in place. However, there are processes in every power plant that are not on the control system. So this is a picture of a chemical tank. And imagine being the technician that climbs up that ladder and literally drops a chain with a heavy weight at the end of it, all the way to the bottom of the aqueous part to get to the bed of solid chemical at the bottom, okay? That is exactly how they were measuring the consumption of this expensive chemical, okay? Seems crazy, and there are reasons I won't go into that they had to do it that way, but this data was collected maybe once a day, but not every day. And depending on what was happening in the plant, they might even stop taking measurements for a week. And then that was recorded into a spreadsheet that was literally created in the early 90s. No one really knows who created the spreadsheet in the first place, but it's been handed down through the generations of power plant engineers, and accumulated knowledge and new fields get added to that without any real documentation. You can imagine lots of missing values. Now, try to be the vice president over the power plants and asking your engineers to do something with that data to help manage my chemical costs. Well, it's darn near impossible. In order to map the very precise, highly governed data with this obviously very ungoverned, imprecise data, never really went anywhere. And they tried it every so many years when the chemical cost would peak, and then they would give up, and then the cost might come back down. They would peak again. So this was just an age-old, decades-long problem that was never solved, essentially because there was no data governance. The data governance was in question, and really the engineers, pretty self-reliant kinds of people, they didn't want anybody coming in to try to manage their data for them, right? And, wonderful people, and power plants are kind of their own culture. So again, culture crops up here, but there was no data governance on this, which made it impossible to manage that cost, all right? So that's an example of governance. I'm not gonna try to precisely define it here today. Rather, I'm going to show you an example of how data governance can be done with some relatively simple tools, okay? So this is kind of where this has all been leading to. What do? Well, we do data lifecycle management. That was the whole premise up front. At first glance, this diagram might look a little bit busy, but it's actually pretty straightforward. If you look in the bottom left, just think of like data in any system or source, core system data, okay? It could be an application, it could be a spreadsheet, it could be a live, it could be a real-time feed, whatever it is. Obviously that data has to have some kind of metadata, whether it's recorded or not. So where is the data? How's it structured? What does it mean? That metadata needs to be gathered into a data governance platform and a complementary metadata platform, okay? And that's the bottom tier down here. And then the raw data needs to flow to what we call a data quality engine. And then once the metadata and the actual raw data are pulled into those, I'm gonna call them platforms, we'll go into a second. Once they're in there, now you have kind of an interaction between the two. So in this block of data governance and metadata, you now have a place where business experts, non-technical business experts, you might call them data stewards, you might call them data owners, there's all these roles, can go and look at the data elements themselves and say, oh, this field in this table means this to me or to the business or to my department. And that gets documented, okay? And that business rule, once it's formally documented and approved or certified, can flow to the data quality engine. And then the person using the data quality engine is a data quality analyst. That data quality analyst can then write a data quality rule, which either mirrors the business rule or is in somehow downstream of the business rule. And then that data quality rule can actually be applied to the actual data to say how well that data conforms to the rules that the company has defined. I'm pausing to see if I'm getting some head nods, right? That's a lot, because it's not like a simple query connect, get my data back. This is kind of like an umbrella or a canopy over the typical ETL analytics lifecycle, all right? And notice there are some very non-technical people involved, right? So once you get to those points, you can now actually have data quality scoring and you can have data certification, which gives you the credibility to walk into a presentation with a seal of approval and a data quality score that proves that this data has gone through a governance lifecycle, and now no one can refute you. I mean, in theory they can, but it's hard to argue against, all right? So that is the data lifecycle management in a nutshell, all right? So the next few slides are some screenshots of a product suite called Data 360. And Data 360 is the product suite of a company that we partner with called Infogix. And my company is technology agnostic. We have lots of vendor partners. Infogix is one of them. We have a sample data source that is based on the New York City Flights 13 data. If any of you are our users or fans of our studio, you probably know this data set. So it's all the flights that left New York City in 2013. What we did is we actually went to that and looked for the data sources. We went to the sources and then built our own database because we wanted to have something that was really big and scalable. So we went back to 2008, all airports across the whole country. Okay, so we've got like 2008 through 2018, all of the flights, domestic flights. And then we joined all that to the weather data that apply, and we joined that to the mechanical information about the planes. Okay, so we've got this illustrative database. We're not aviation experts, but it's really easy for people to relate to flights. So launching into the governance tools, this is the product called Govern. It's part of the Data 360 suite of products. And I know you can't read all this, but what we're doing here is defining a business rule called multi-flight tail number per hour handling. That's a mouthful, but what it is in this database, we realized that there were planes that were scheduled to depart, the same plane leaving a given city for two different destinations pretty much at the same time, within minutes of each other. And that just can't be, right? What is going on there? Well, what we realized is that usually one of those rows had a null departure time. So you can delete it. In other words, that flight never happened. So that plane got assigned to a different flight, okay? And so it's a really simple concept, really in practice. But this is illustrating, this simply cannot be. And in such cases, delete the row that has the null actual departure time. So real simple. Down here, you can see, well, maybe you can't, but this is defining the roles. There's a section called definition of the business rule. There's a section called ownership. And in the ownership block, there's like a data owner assigned, and that just happens to be me here. That isn't always going to be the case where the analyst is the owner, right? In fact, it's probably not going to be that. And then you have the data steward. That's my colleague, Brian. And we are interacting with each other to start governing this business rule, okay? Now, the business rule involves a number of different fields. In order to make that rule happen, you need more than tail number. You need like, when was the flight supposed to depart? When did it actually depart? So there's numerous data elements in there, okay? So what's happening here is we're selecting one of the data elements. It's called tail number. It's just the identifier of the plane. This is a screen that when I first log in, I can see, oh, I've got to go in and certify one of the fields that belong to this rule, okay? It says, these are my assignments in the data governance process. I have to go in and certify this because we're trying to implement this business rule. So I actually get a push notification to my phone from the Data 360 workflow, and it is telling me, hey, Brian, the data steward, has set this up for you to go in and certify. So go in and review it, all right? So I go to the link, and this is like a mouse over screen where I have the red arrow pointing to tail number, and there's all the information, the business description of the rule, the research that the data steward has done, what database is this in, everything you would want to know about that particular field that is part of the overall business rule, okay? So after I review it, I submit. And by pressing that button, what I'm doing is certifying that particular database column, which is part of the overall business rule, as certified. So if I'm the owner now I have given the authority to say that is a data element that applies and it's been inspected and we know exactly what it means, where it is, and so on. And like I was saying, I mean, I know this is, you can't see all this, but there are multiple rows here to represent the multiple data fields or elements that are part of the business rule. Okay, so each of those need to be certified. And once they're all certified, that business rule is now totally valid, and we know with confidence that it's being properly implemented. So that was the business rule. If you remember the flow chart I had, the business rule has to be kind of in combination with a data quality rule. And usually that data quality rule needs to be written separately, but it's based on the business rule, okay? Not always, but usually, all right? So this might look familiar. This is kind of like an analytics workflow or pipeline that you might use if you're not using strict programming code. There's lots of tools out there that have this sort of look and feel. This is a data quality pipeline where you're taking the raw data and applying the rules, the data quality rules to it. And ultimately you end up filtering out that row that has the null departure time. And so it's the data quality rule that couples to the business rule, all right? Once that's executed, you can now do data quality scoring, all right? And this is a graph of the data quality for that particular field over time. And this little tiny red column on the left was the number of rows that had the null departure times. And after the quality rule is applied, we essentially end up with perfect data quality. So now we go back to our executive who didn't believe us before, and by having certified data through all this governance process and data quality scoring, we have a data quality score of 100%. We have certified business rules on the data that we are interested in looking at. And now Ron Burgundy is saying this just in, I approve this analysis, okay? So I hope that all kind of flowed for you. That's a lot. Like I said, it's typically the data scientist or analyst or analytics team isn't always thinking about this stuff, but it's so important. That's why I want to deliver it to you today. And I hope that it helps. I hope that you can take this back. The elements in here are data lifecycle management, culture, how important culture is on data quality, which without that, you really don't have a solid analytics leg to stand on. And then finally, there are tools out there, not only Infogix, but other tools. We like Infogix because we think they do a good job of handling all the pieces and they integrate well with each other. You can find like a data governance tool, you can find a data quality tool. They do a good job of bringing them all together as an overall data lifecycle management platform. So that's why we really like partnering with them. So that's really the theme of my story here. And this is a goofy graphic, but what I was thinking here is that like you're already the data science unicorn in your company. But if you go back with all this knowledge of data governance and data lifecycle management, you're going to be worshipped even more. Okay, so that's why I have this ridiculous rainbow unicorn thing here. So that's it. I was super excited to be invited to do this, and I'm glad we had a good turnout despite the cold weather. I grew up near Lake Erie, so I'm like, what's the big deal? And Tom's from Syracuse, New York originally, so we're like, it's not snowing. But thanks a lot. So that's it. And I'm field any questions. Yeah.
Really good, great talk.
Thank you.
So I was just curious if you could probably give like a more concrete example of how you would, or go about scoring, or like a metric that you would use to determine, the quality of the data.
Yeah. So there's a plethora of slides and content on data quality scoring out there. I guess if you think about what I just showed, that was a quality rule that was like, okay, sometimes there are things that occur that create null values, and we just want to eliminate those rows. Now that they've been eliminated, we know that we got perfect scores, because all you got to do is reduce that, get rid of those rows.
Right.
There are other much more sticky and hairy examples of data quality being a problem. So, if you think about the gas pipeline example that I gave, in that case, sometimes the data that gets collected by the people in the field actually needs to get corrected by a data conversion team. So if somebody enters something wrong, it's clearly illogical, or they entered it in Ohio, but they were in Indiana when they did it, for example. That whole team of data conversion and data quality folks is going to be using tools like this to go in and they're going to score and say, oh, there's like this year we've had 15% of the gas pipeline inspection records that were just obviously wrong. Okay. And so as you apply that labor force to going in and correcting data in the data quality tools, now you end up with this, we don't want to call it corrected, but we call it curated or certified version of that database. Does that help at all?
Yeah, so it's based on standards that's established.
Exactly, yeah, right. So in the same way that I went in and I wrote a business rule that the data steward then researched and implemented, the data quality analyst is doing kind of the same thing. It's kind of like you got to have the business policy or definition, and then you have to have the mirror image data quality rule to implement that. So the data quality analyst has a big job, right? It's really important. And what's good about these tools is that it keeps an eye on how well that data quality score is being adhered to, right? Is that helpful?
Yeah.
Am I answering your question? Okay.
Thank you.
Yeah.
Yeah, I think the complexity of it gets even more so. You can do simple profiling and heuristics. What values were in the columns? You can have a single business rule, and then you can start to look at data and relationships, which you can't do until you really fill out this conceptual understanding of how it is, and then you can understand it. It would be illogical to test a gas plastic pipe for corrosion, right? That's a series of relationships. Now you can start to study your data in relation. The other thing is that the data is not static. So you may fix it for your analysis, but there's still more coming in the front door. So you have this responsibility to continue to study it until you can implement the rules on the front end and improve data over time. So you're kind of doing a dynamic flow of data.
It's a very complex problem.
So Tom and I have worked together for a long time. And when we first formed the corporate analytics team at a company we used to work for, I was the first data scientist. I'm like, yes, let's go do predictive analytics.
Isn't that how we all get into it?
Yeah. And oh man, I was mad at him for a long time because the data was crap. And like, what am I doing here? And what do I do now with my career? Well, I began to love data governance, data quality, and it was a pain at first, but now I'm really passionate about it.
Yeah.
Because it's so important. You're not going to be able to do deep learning on any kind of gas pipeline thing unless you have really good data. So, I'm trying to imbue a little bit of passion around this with this hopefully fun presentation. And people really begin to appreciate this when you can use analogies and stories to explain, well, why do we need all this architecture for doing data governance, Can we just get started with the analysis when sometimes no?
Right, because garbage in, garbage out.
Yeah.
You can do all the modeling you want, but if the data, you don't understand the data, or there's just these oddities in the data, you can try doing all these modeling and you'll get anomalous results because you don't understand the intricacies of it. So
right.
Absolutely. I'm a huge proponent of anyone's wanting to get into data science and talking about organizations. I always say, be careful, because unless an organization has a strong analytics group and a strong data engineering group, which hopefully somewhere in there is some semblance of data governance and data quality management, data science can never be successful. It's just, it's impossible because you're going to spend all of your time, like you experienced, doing just that.
Yeah, right. Please.
Yeah, I think to speak further on that point, it's really interesting in many organizations I've worked for, the data analytics, the very glamorous part, what are you doing Tableau, what do your graphs look like? But the data quality is the very unglamorous part.
Yes.
But to me, definitely much more appealing because it's really where the essence is. And I guess I wanted to talk to you about a challenge that I've seen in lots of different organizations that I've worked for. And it's I think when we talk about that person that's collecting the data, and what is like understanding better like what their motivation is or how to increase that quality of what they're collecting. So for example, like I've worked in a lot of places where we ask people to collect data for all types of things, right? And we might tell them why, and you know, things might change over time. The form might go from a 10-minute form to a 30-minute form. But one thing that I really see lacking, that I see it's a huge barrier, is that people are definitely like, for the most part, willing to do the work, like willing to understand why it's important.
Yeah.
But one thing that I see that they rarely get is feedback on their information, right?
Oh,
So like, for example, if I was let's just say a health analyst collecting data on patients post-surgery about how their recovery is going, right? I'm happy to do that. I know it's serving a great cause, but wouldn't it be great if like once a year, someone took my data and said, this is your data plus the other 50 people that are doing the same thing, and this is what we've learned from it, and this is the changes that we've been able to make. Like, I feel like understand, like, I don't know, maybe that's something for me personally, but like understanding like what you're doing and kind of what the bigger purpose that it's serving, I feel like that's really, really lacking in kind of making that connection. And I think it would just improve data quality, like improve communication across the board.
Yeah, well, I mean, great observation.
Yeah.
I'm thinking of all kinds of
Yeah.
additional thoughts that you just brought up in my mind. And I guess the first thing I would say is maybe like, you know, there's this concept of the 10x software developer and then the 10x data scientist. Really good data scientists want to meet the people collecting the data and understand the daily life and all the things that affect the data collection. And that's good for everybody. Makes the data collector feel much more appreciated that they have, oh, there actually is somebody using this and I'm collecting all this data.
Yeah, they know my
I didn't
name.
even know why.
Yeah.
I've never met you before, you know, thank you. But not all cultures allow that. So another aspect, and I want to hand this off to Tom because he's lived through this a lot. You know, the front end design of a process, of a data gathering process, is such a cultural endeavor. You know, like with the gas pipeline stuff, like when they went from paper forms to I forgot to call it, we had to call it an asset management system or a work management system. Like those forms were horrendous, you know, and it really almost affronted the people that had to collect the data. So nobody asked them what the forms should look like, right? So that's my alley-oop to you if you want to say anything else about that.
I think Josh was talking about the cultural aspect, and you get inside of a corporate organization and you think about it. You've got the IT people who are disconnected somewhat, but believes they're partners with the business people that actually do the work. The business people don't fully understand or appreciate the technology and the databases and all that. The IT people don't do the job, so they don't really understand all the data columns. And then you got the analyst, data scientist who just wants to look at good data. and then you think about the front end design. IT people, that's why there's a big focus on UI and UX. But if the UI is badly designed, you're going to get garbage in, garbage out. Well, why would the UI be badly designed? Because we never took the time to capture the conceptual metadata to understand the business use. Therefore, we didn't have good business rules. And then without good business rules, I can't assess data quality. And then you're into this horrible cycle of just collecting bad data, and it perpetuates itself. And so that becomes the question is, we joke about those all the time, but why do people demand to know where their food came from? Why do they know the lineage of their lunch, like Josh was talking about? But we'll make a multi-million-dollar decision based on data that we don't really understand. And so that's in today's day and age, if you want to survive the next 10-year window with the explosion of IoT and people coming facile with analytics, you got to up your game. Data should be certified. And so that's kind of our play.
And I think like the data collectors and how they feel and what they think and what their experience, that's all about the culture stuff that we're emphasizing here, which is why we really believe in our practice, like data strategy is just as much or more culture change than it is analytics and data management.
Just a concrete example, we designed a screen, we wanted to capture the pipe that was put in the ground, and it came in various diameters and pressure capabilities. And time was short. We had to get the project done, so we designed the UI. So we put a reference table in that listed all 5,000 options for plastic pipe. First one on the list was 2-inch plastic pipe. After 3 years, guess how much 2-inch plastic pipe was in the system? Right? Because there was no rule to test it. So I'm just going to pick the easiest one because you guys are idiots. I'll keep doing it on paper. This is what I care about. So culturally, they didn't trust the system. I'm going to maintain my own records at double the cost, as Josh pointed out. And we're populating into the system, which was supposed to make us fact-based and data-driven, garbage data. It's crazy.
So I know we're already over.
We are.
I can talk all day, but wanna
No,
respect the time?
yeah, and of course everyone's free to stay after, but let's go ahead and just kind of wrap things up. I'd like to thank Josh again for coming out.
Yeah, thank you.
Thank you, Belmont, for this venue, and Nicole for bringing delicious coffee and food. All right, thank you, everyone.
So our contact info is all up here.